So, my name is Camilla Feurst, and thank you so much for joining. I come from Statkraft. It's a Norwegian energy utility. And today, I'd like to share with you how we think we can get more conditional insights through applied machine learning. I also wish to say something about how we, as a small team, still think we can get a huge change and a transformation in how we make decisions. So, first, about Statkraft. As you can see, we are widely spread across the globe, but still, our main focus is in the Scandinavian countries and mostly in Norway and in hydropower, which is today's focus. We're also extremely proud to be Europe's largest producer of new renewables. So anyway, I'd like to set the stage for hydropower before we move into our use case. So in the left corner, you can see a power plant in south of Sweden. And as you can tell, it's old. It's over 100 years old. And I think this is typical. Our units, our power plants, they were built to stand, to be reliable. These are grand old ladies that just keep on running, and they are amazing. And even though this one is quite an exception, in average, if we move to Norway, the average age is still high, roughly 50 years. But the typical power plant in Norway is located inside a mountain. Most likely, you just see an entrance, and then you go down a tunnel, maybe for 1.5 kilometers inside the mountain. And then you enter a machine hall, like the ones you see to the right. And down here, we have immense powers, huge forces going around. It might be as much as 500 or 600 meters of water head pressure, and you can have a runner with a weight of 7 tons, and the generator might be as heavy as 300 tons. So I think you understand why these were built to be reliable. They are not allowed to fail. And that's how we want to keep it. We cannot have failures with these powers. The operation must be stable. And if I deep dive into our failure statistics, I can really see this. Over 10 years, we haven't had more than 3 failures with a duration over 3 months. So if I deep dive into our operational data, and if I'm looking for fancy failures to train algorithms upon, I'll be disappointed because the data is quite boring and there's a lot of normal. Still, even if current operation is really stable and reliable, we are facing new challenges. The first one, I think you can understand. We have aging assets and they require reinvestments and maintenance. So the timing must be done really good. And secondly, and maybe the biggest challenge of them all, is that we are losing 1/3 of our most competent workforce due to retirement the next 5 to 10 years. These are people that's been around in our power plants for maybe 30 years or more, and they just walk out the door with all this competence. And third, we have challenging market conditions with other technologies being less capital intense. I think digitalization and applied machine learning might be our best friend when facing those challenges. But you might wonder how, and I'm going to tell you that. So, heading back to those people in our power plants that's historically been present in power plants, our field operators, maintenance technicians, managers, you name it. They know their power plants. They've been around for a long time, and they have been in their power plants almost daily. So I consider them as walking machine learning algorithms because they process all the information in their power plant each day, and they come up with a judgment, with a conditional insight about the status of the power plant. So if I work closely with these guys, and if I understand what they are listening into, I might be able to transfer that knowledge into sensors. So that's what we are doing. And I have as an ambition and a saying that I'd like to transfer their senses into our sensors. I then think that I can overbridge the competence loss, and I can gain and implement their know-how into our sensors. And then in time, I think we can make new discoveries because computers can hold more dimensions, and also we can share the knowledge easier. And I think this is a really good true example. In the picture here, you see a maintenance team in Region Middle in Norway. And apart from me and my colleague Pia with blue hats, I think you can tell that the average age is quite high. The average age is 60 years, even though I have an apprentice standing to the right in the picture. So I will basically lose all of them within 5 years. And they've been there for 30 years, plenty of them. So this is a true challenge and something we are really facing. And I also think that this is a good example of how they are using their senses. Because my main character in this story is standing in the middle of this picture to the right of me, and his name is Steinar. And he walked into his power plant on a Friday afternoon, walked into the generator room, and sensed slightly odd temperatures, slightly odd vibrations, no good vibes. And he actually called his manager, and they reasoned back and forth, should we stop the unit tonight? But good prices were on, and it was decided to have a planned outage on Monday instead. So what happened? On Sunday, the unit failed. So Steinar managed to predict this failure 2 days before it happened. The failure that Sunday afternoon was a minor failure, no big deal, but it gave us a clue about the symptoms this faulty component had, and I'm going to tell you about the severity of these symptoms and why it was true to us to do something about it. These are pictures from the generator, and to the left you can see the rotor that is rotating inside the stator, and to the right only the stator. And this component is huge. I mentioned those 300 tons, and I'm not exaggerating. The rotor in the middle has a weight of 170 tons, and it rotates and induces a magnetic field into the stator with a weight of 140 tons. But still, this tiny air gap is only 25 millimeters. So even though this is like a massive piece of construction, the construction is so delicate. So these temperature deviation that my maintenance manager felt, it was a sign and could be a sign of a deformation in shape. And you don't want to have a deformation of shape on 140 tons rotating with an air gap of 25 millimeters. So this is why this tiny failure was considered a severe symptom of something that could happen. And before we could do anything about this, we had to monitor it thoroughly. So it was decided that nonetheless, we need to go and buy a new stator. We have to do it. But the lead time for those components are 2 years. And this is a single unit. We have roughly revenues of 150 million NOK each year. So we can't have it out of operation for 2 years, or we can, but we'd rather go monitoring it thoroughly. So that's what we did. And there are just a few other pictures. Here you see the rotor to the right and the stator to the left. So said and done, what did we do? We were concerned about the stator. Steinar told us where to mount new sensors. We managed to get the data online, and then we processed and analyzed and visualized the data into dashboards. We set up alarms according to the anomaly models, and we send notifications in text messages or emails. We also send monthly reports because Steinar, he loves our dashboard, but he is a bit old-fashioned and still prefers his monthly report. So of course, we also send him the long-term trends and the developments in a monthly report. And to keep everything updated, we have monthly recurring meetings with Steinar and his manager, and we discuss developments, retraining our models, and adjustments that we need to do. And by now, we are really happy with the development here. We have managed to find a way to operate this unit without putting on extra stress on the faulty parts of the component. So the running is now stable. We have removed operational restrictions, and we feel confident that with this unit will be running and be kept running until the new stator is in its place. But even though this was our first use case, me and my colleague Pia, it was still a true and valid case that we had to deliver a stable condition monitoring service for. So we decided to go and build an analytical platform that would host all these services. So we have built an analytical platform that we call Promo, the promoted actions. It's built upon Docker containers, and we have services running. We can run models whenever we wish. We can have notifications sent, and we can have monthly reports or weekly reports, whatever you prefer. And we have test coverage on all our services. And we also have a local storage of all the historical data so that models can process quickly enough. So we only continuously transfer the online data. And this also gives us a really nice scalability onto future use cases and a good overview of the models, and they can really easily be turned on and off. So if I move to the model page, I can see my promo models for this specific stator. I can turn them on and off, and I can edit them if I wish to. So what was it that we decided to do with this proof of concept, and how do we wish to go about this now? We have this ambition that each use case can have experiences and generic features that we can transfer. And it's actually quite nice with that first presentation we heard today about transfer learning, because I think this is actually nailing it down a bit in our case as well. Because we think that if we can create an open platform, it's not just ours, it's an open platform with a model library, then this transformation is going to catch momentum and take place so much quicker. So we decided early that each use case, we should withdraw generic features and add them onto a model library. And then we can apply these across fleet. For example, this stator we have been talking about, it has a specific construction. And now we've learned so much about this, so we can apply these models on other stators with the same construction. But we are not only happy with our own use cases, because we want to have more people giving us new contributions and new correlations to look into. And we wanted to be able to invite in both non-scripters and scripters, because we think that a lot of those people that are holding domain knowledge are not typically scripters in our environment. So how could we do this? We decided to open up the platform for non-scripters. So, for example, maintenance managers or discipline experts, they can just walk into our analytical platform and they can apply models from the library on their own data sets. But of course, we also want to invite in new scripters or whomever who has scripting knowledge to help us expand this library of models. And that's also what we do. So anyone who is fond of Python coding can also go and add their own models. So by doing this, we think that we can accelerate the transformation and the change without being role specific, who's doing what. We just invite them in and ask them to contribute. So we extract generic features, we build our model library, we apply generic features across fleet, we invite in people with domain knowledge, typically non-scripters, and they can apply models to their own data set. And of course, also scripters invited. Add your own code and use our services. And then we can use their use cases and pick up more generic features. So this is how we plan to go about now this year, and we have just started inviting in our first end users. So we are really excited about this, and we think that this will be the way to go in order to change our organization. When we started that first proof of concept, and when we took the decision to actually build a framework around it, that was hosting everything. And when we made the decision that that framework should be both generic and scalable, we didn't really know where this was going to lead us. But today, I'm super happy we did. Because the last year, we have 5 different use cases that we are working with. And we have been able to use our framework on our analytical platform for all of them. And it has proven so worth all the time we spent on it. So today, I just have a few examples here. One is our audio surveillance case, a project we ran last summer. And we are trying to find out whether or not we can get more conditional insights from mounting microphones inside the power plant. Can audio be a new way to gain insights? And then to the left, we have Power Plant Set, where we are investigating new components, brand new components that we thoroughly want to monitor in the very early phase of their lifetime to avoid those early failures. And then we have another power plant quite similar to this stator that we started off on, where we could actually use exactly the same models. It's the same construction, and we could just apply them all over again. And so far, it has proven very useful. And we are also opening up for wind analysis. So wind typically have more generic components than hydro have. And we tried the scalability of our analytical platform by providing wind with one park analysis, basically just applying the same analytics on plenty of turbines. And this is just in the very beginning, but it's going to be interesting to continue and also apply more advanced analytics to park analysis. So I'm not sure where this is going to lead us, but I am absolutely convinced that if I invite people in, I will get so many good new ideas that I would never have thought of myself. And nonetheless, it's going to lead us to somewhere amazing. So my last saying is just that be brave, invite people in, be open-minded, and don't be afraid to be scrutinized for the work you're doing. Just invite people in, and in time, this is going to be awesome. But I'm not alone with this, of course. It's not only those invited in end users. I have an amazing team to my help. And first of all, it's Pia Zacharias. She's head of analytics. And it was me and Pia that started off on that very early analysis on that first stator. Then I have Andreas Solberg, who is head of the architectural design of the platform. And Sebastian, who's making everything fancy and nice in a UI. And Sigmund, who's brand new on the team and helping us out with everything. So with that, I just want to end by saying that we would love to share what we're doing, and we would love to share both models and data. And I was even hoping that maybe when this Corona thing is over, it would be awesome to have some kind of hackathon with predefined data sets and one failure, and invite people into a competition of finding that failure in the most efficient way. So we are very willing to share, and let me know if you have any thoughts regarding this. Thank you so much, and thank you for joining.